Welcome to Behind the Build, presented by ATL BitLab. I'm Stephen DeLorme, and this is a podcast where we talk directly to Freedom Tech builders about their latest projects. On this show, you are going to hear about topics like Bitcoin, the Lightning Network, privacy, cyber computing, decentralization, and all kinds of cool stuff. This episode is sponsored by ATL BitLab. ATL BitLab is Atlanta's Freedom Tech hackerspace. We have co-working desks, conference rooms, event space, maker tools, and tons of coffee. There is a very active community here in the lab. Every Wednesday night is Bitcoin night here in Atlanta. We also have meetups for cybersecurity, artificial intelligence, decentralized identity, product design, and more. We offer day passes and nomad passes for people who need to use the lab only occasionally, as well as memberships for people who plan to use the lab more regularly, such as myself. One of the best things about having a BitLab membership isn't the amenities, it's the people. Surrounding yourself with a community helps you learn faster and helps you build better. Your creativity becomes amplified when you work in this space. That's what I think, at least. If you're interested in becoming a member or supporting the space, please visit us at atlbitlab.com. That's atlbitlab.com. All right, on to our show. All right, back here with the ATL BitLab Behind the Build podcast. I'm Stephen. I'm here with some people from Alpine Labs. Would you guys like to introduce yourselves?
Yeah, so my name is John Light. I work on product at Alpine Labs. And
hi, my name is Storopoli. I'm in the engineering team at Alpine Labs.
And so we're actually here at TabConf right now, the Atlanta Bitcoin conference. So apologies if there's any background noise, but actually Jose was working out of ATL BitLab while he was in town, and I was asking about what he was working on. He was telling me he was working on ZK stuff, and that he recommended that we connect with Light at the conference and do a podcast. So we're here to talk about what they are working on. Why don't you tell me about what Strata is?
Sure. So Strata is a work in progress ZK rollup built on Bitcoin. Mm-hmm. The purpose of Strata is to add additional programmability capabilities for BTC so that we can build new kinds of applications, including new kinds of scaling protocols, new kinds of privacy protocols, new kinds of financial applications for BTC.
Very cool. And so this is built with a rollup. I'm going to admit that I'm still trying to wrap my head around exactly how rollups work. I'm more of a Lightning guy. Though the rollups sound fascinating, I think I just haven't I haven't had a really good digestible explainer yet for the moon math that is it.
Yeah. I was going to say, come to my talk. I'm doing a Bitcoin Rollups 101. I'm not covering the moon math, but basically almost everything else about.
Okay, well, I'd love to see that then, because for example, I don't know how the math of SHA-256 works, but I've had it explained to me the kind of assumptions you can make about elliptic curve cryptography and how you can only compute this in one direction and the other, and so I trust the mathematicians that that works. And once I know those kind of primitives and how it works, I feel a little more confident about it. So
sure, yeah.
How exactly does Strata work?
So currently, Strata has a few different moving parts. One is a bridge, and currently it's just a MuSig2 based bridge. So we're running a network of signers who are signing a N-of-N MuSig multi-sig. To actually custody Bitcoin on a Signet test network. And once a user deposits Bitcoin into this multi-sig, they will receive an equivalent amount of Bitcoin on this other blockchain, the Strata blockchain, which is running kind of in parallel to the Bitcoin Signet. And they'll be able to do EVM compatible transactions, peer-to-peer payments, smart contracts. And when they make a transaction, that gets sent to this entity that we call the Strata sequencer. And the sequencer sequences transactions in a particular order, packages them into a block. These blocks are produced approximately every 5 seconds.
Wow.
And then Periodically, the sequencer will package these blocks into a block batch, generate an execution trace for the block batch, pass this execution trace over to a prover, and this is where the zero knowledge computation happens. The prover is going to like ingest this execution trace and spit out a zero knowledge proof that the execution trace is valid according to the rules, like the consensus rules of the Strata protocol, and then pass the proof back to the sequencer, and the sequencer will then post a commitment to this execution or this execution trace or the block batch along with the zero knowledge proof in a transaction on the Bitcoin Signet. And then, it'll get confirmed in a Signet block. And then after so many blocks, the Strata protocol will consider that batch final.
And how often does it go onto the main chain?
It's periodic, so it could be like once every 30 minutes, once every hour or something like
Got
that.
it.
It's a configurable.
Got it. Yeah. I think were you going to say something?
Yeah, one thing to note is that this Signet, it doesn't change anything from the mainnet. We are not using any soft forks, so no opcats, no opmo, and it works in plain Bitcoin right now. The only thing that our Signet does, different from the mainnet, is that the blocks comes at 30 seconds instead of 10 minutes. That's the only thing.
I gotcha. Yeah, kind of a MuniNet style situation.
Exactly.
So let me see if I can repeat what I just heard to make sure I got my head wrapped around it. So it's like, okay, let's say, so I'm a user, I want to kind of start using Strata. I would take some Bitcoin and I would deposit it, and this would go to a MuSig, multi-sig. And I guess I might call it maybe pegging in. Would that be maybe a good term for it?
Yeah, that's how some people have talked about it.
So I peg it the Bitcoin in. Then I'm given some Bitcoin on the Strata chain. From there, if I want to make transactions with this Bitcoin on Strata, I'm going to submit transactions actually to a sequencer. The sequencer, I guess, sequences people's transactions, put them in order. Strata has its own blocks, which I think you said were 5 seconds. And then those blocks are arranged by the sequencer. Every once in a while, the sequencer takes a batch of those blocks and they create an execution trace. They send the execution trace to the prover. The prover does the zero knowledge math stuff and generates a zero knowledge proof. Then they send that proof back to the sequencer, and then every once in a while, the sequencer takes those proofs and publishes them back to the main chain in a Bitcoin transaction.
Yeah, and that's the point at which Strata full nodes who are watching the Bitcoin main chain will say, okay, that batch is like final.
Okay.
Or, if you're a recipient of a transaction, you would look for that and you would say, okay, it's been confirmed, and it's going to be, because it's on Bitcoin, it'll be very hard to like undo that transaction.
So I guess it could be like if there's every 30 minutes, I guess there's still a ton of on-chain activity for a roll-up like Strata. Is it correct to call this a roll-up? Or do we?
It's a work in progress roll-up. Currently, we only put commitments on chain. Technically, a roll-up would be if we were putting the full state data on chain. But this is just basically because right now we're testing the execution environment, and later we'll test the actual like data availability mechanism and like add the on-chain data as well. But
I see.
If it's easy to talk about it as a roll-up, you can call it a roll-up.
Okay, got it. So, but what was the word you used? It wasn't a roll-up.
It's more like a commit chain.
Because
we're just putting commitments to the state in Bitcoin as opposed to the full state data.
So really, it's almost like if you want to like, I guess, validate this on your own, you have to have. You need to be able to see the Bitcoin blockchain, see the like proofs that are or the commitments that are published there. You also need to have the state data from the sequencer.
The state data is mainly important, or will mainly become important for when we implement the full BitVM based bridge. I mentioned that the current version of the bridge just uses MuSig 2. But this is technically only what we call the cooperative path or the happy path of our a full bridge protocol. There's a second path, the uncooperative path, which actually uses a BitVM2 based program to enable the bridge to continue to make forward progress, even if only a single bridge operator is actually functional and following the protocol. So in the happy path, you need cooperation from all N of N bridge operators to process withdrawals. And in the uncooperative path, you only need one single bridge operator to be online and willing to process the withdrawals. And the security model, they can't just like run off with all of the money. Anybody will be able to challenge them if they try to make an invalid withdrawal transaction.
I see. And this is still like a hot area of research. So we don't know if it is possible to make a trustless bridge, but maybe this is something that we might be able to do it in the future as well.
And like, help me understand like what the landscape would look like. Like, so obviously we're, this is under active development, but like, let's say you have a, world where people are like using Strata, like how many bridges do you envision there would be?
Well, for Strata, there will only be one bridge.
Okay.
There'll be one canonical BTC bridge. And this bridge will be somewhat tightly coupled with the consensus of the rollup itself, because the bridge needs to know like what the canonical version of the Strata chain is in order to know whether or not a withdrawal is valid. And so, yeah, there would be a tight coupling there. So there would just be one.
Okay,
BTC
one bridge.
Yeah.
All right. Well, I guess I'm confused. I thought a second ago you were talking about like multiple bridge operators.
There could be bridge operators, yes. So there's one bridge, but multiple bridge operators. And if we want to drill in on the bridge protocol some more. So the bridge is what we call just the protocol that users are using to transfer BTC from the main chain to the Strata chain. And the bridge operators are participants in this protocol. So they are watching the Bitcoin chain for deposit requests, and they will come together to create an address that the user can send some Bitcoin to make a deposit to the Strata chain. And then whenever users want to withdraw their Bitcoin back to the main chain, they're going to be watching the Strata side of the protocol. And when those withdrawal requests come in, they will first try to go the cooperative path. And so they'll signal to all of the other bridge operators, hey, there's an incoming withdrawal request. Let's make an N of N MUSIG transaction to send the Bitcoin back out to the user on the main chain. And if for some reason one or more other operators is unresponsive to that request, then they go the uncooperative path. And this is where the BitVM challenge and response game kind of comes into play. The operator will first try to, first they'll reimburse the user directly out of their own Bitcoin wallet. And then if the other operators are unresponsive to their request for the cooperative reimbursement, then they will take a pre-signed transaction that they created during the deposit process, and they will put this on Bitcoin. And this pre-signed transaction basically says, in 1 week, this operator will receive the Bitcoin as a reimbursement for the Bitcoin that they kind of already sent to the user. And at any point during this 1 week period, anybody else can come along with another one of these pre-signed transactions and basically say, hey, you didn't actually send that Bitcoin to that user like you say you did. We're going to challenge that. And then this like challenge and response game starts, where the operator then has to kind of put all of this data about the withdrawal that they did on chain and like a proof that the withdrawal was valid. And then finally, another user can come along and put another proof on chain that says that actually that assertion is invalid, and we are going to stop that withdrawal from happening and kind of punish the operator for trying to make an invalid withdrawal. So that's the whole BitVM side of the bridge. That's still like a work in progress. But for folks who are interested in like the more technical details of exactly how that works, there was an interesting paper that was published by Robin Linus and a few of his colleagues, the BitVM2 and BitVM2 bridge paper.
Okay. So, and what, like, I guess I'm struggling to understand the difference between the bridge operators and the bridge itself. I mean, like, is the bridge just like a server, or?
No, the bridge, it is the kind of totality or the combination of these different moving parts.
Okay.
The bridge operators having the music path and having the BitVM path. And then having, the software that actually watches Bitcoin for deposits, watches Strata for withdrawals.
I see.
And all together, we kind of abstract all of these different pieces and just package it all together and call it a bridge.
Okay, I see. Okay, so that's helpful to know, because like when you say, like, I think when I said how many bridges do you said one, I just imagined that I was equating the two in my mind, the bridge and the bridge operator. So that's helpful to know that the bridge is actually a lot of moving parts together. It's a lot of bridge operators. And so it sounds like the happy path is all the bridge operators agree. Things can move a lot quicker and smoother when all the bridge operators are in consensus, and when one or more bridge operators are not in consensus with the rest, then you have to go this extra path, this harder path, and that's where a lot of this like challenge response kind of stuff gets involved.
Exactly.
You had
And maybe one thing that we can also go, like, this is a kind of like builders podcast, so to discuss what we are building, we can go like to more like technical details, or more like what is needed to build Strata. Because we have like different fronts, and everything is open source. You can go to our GitHub page. I think we are going to put those in the podcast show notes. But for example, we have the whole prover side of things, that we are doing all of those proofs and all of the circuits that we are building to make those proofs possible. Then we have the P2P on the bridge operators. We also have the whole how it's gonna handle and deal with Bitcoin. So we have a lot of like music too going on, Bitcoin pre-signing of transactions, creating transactions, broadcast transactions, how to interface with the layer one, which is Bitcoin, with the Bitcoin layer. And then we have the EVM side of things. So how do we validate all those smart contracts, do the transactions? Is the different UTXO system, is an account-based system. So all of those things, there are a lot of moving parts, and they are all open source in our repository. Also, we have like CLIs and binaries and user interface that we are building. So we have a wallet. We have also tons of documentation on how users can get into Strata, and we can dive into any of those details, but there is a lot of moving parts and a lot of complicated problems to solve.
Is this a big team working on this?
We currently have, I think, around 16 engineers.
Wow,
something like this.
That's pretty decent sized team for a startup. Wow.
Yes.
Very cool.
And we are very focused on the engineers, so I think that 80% of the team is engineers. So
wow. So like maybe dig into a little bit on the like what it would take. So like you said you have CLI, you have a wallet, all that. Like what would if somebody wants to start using this today, what would they do? Yeah,
so we do have a CLI. It's called just the Strata CLI. It's one of the binaries in the repo here. If you go to the bin
I see
directory, there's
bin and Strata CLI.
There we go.
And right now, the main functionality of this is to enable users to bridge in and out of Strata. So the user, there's a faucet command. The user can get some Signet Bitcoin, and then once they have that, they'll be able to do like Strata deposit, which will actually send their Bitcoin across the bridge, and they'll receive an equivalent amount of like Strata BTC. And then They can also send the BTC from their Strata wallet to any other Strata address. And so if you already have an EVM wallet like a Frame or MetaMask or something like that, then you can transfer the Strata BTC like out of your CLI wallet into your like EVM wallet, and then start using EVM applications that people deploy to the network.
Is there something in MetaMask that like you can just put in like a custom network?
Yeah.
Okay.
There's a standard for how you can add new EVM chains to an EVM wallet. Some applications just make it as easy as you click a button, you'll get a pop-up that says, hey, do you want to add a network with these details? And then you just say yes, and then it'll open that network in your wallet.
Okay, so it's like somebody would basically, if they wanted to test this out, you'd go here to this GitHub repo, you clone the GitHub repo, CD into here, you'd run the Strata CLI binary, and then there's like a command on there where they can actually fetch Signet coins from your faucet. You'd take those Signet commands, you'd use another CLI command, you'd peg that in, I guess through one of the bridge operators, through some of your Signet bridge operators. And then you would end up in that like local wallet. You'd actually have it. You'd have the I don't know if we're gonna call it Strata BTC for lack of a better word. And then you could take out Strata BTC, keep using it from the CLI if you want to, or you could just download MetaMask, get it hooked up to the Strata network, and then just like send it there.
Exactly.
And then you'd have like a little visual interface for using that.
Exactly.
It's cool you're able to use some of the infrastructure. Like infrastructure is the wrong word. But like MetaMask, it's cool that you're able to kind of like use some of the stuff that already is existing, I think.
Yeah. That was one of the reasons, one of the main reasons I would say why we chose to do an EVM chain is just that there is a ton of tooling, open source tooling and proprietary tooling, but a lot of tooling that works with new EVM chains out of the box. Developer tooling, end user tooling like wallets, block explorers, things like that. It's very easy to... Sometimes as easy as just pasting a URL to just get it to work with your new EVM chain. So,
well, I think I'd like to ask a little bit more. I'm trying to understand a little bit about the sequencing, or actually, what I'd really be curious about is like, okay, validation. Like, what is the exact? What exactly does it look like? What do I need to do in order to validate this chain? So like my concept with Bitcoin is I can run a full copy of Bitcoin Core and have the entire blockchain. If I don't want to do that, then I could use something like Explora and just get it from kind of like a trusted API. Or I could do something with like compact block filters, like run like a light client or something like that. What would actually be the requirements or expectations if you're like having a Strata wallet or whatever? Like how does that like validation work?
Yeah, so right now there are two ways that you can do it. One is like you run your own Strata full node,
okay.
And the code is in that repo. And if you do that, then
is that Strata client or?
So actually, a Strata full node is two pieces of software. It's the Strata client and the Strata ref. And the client is basically validating what we call the orchestration layer. And that is a software layer that handles the bridge transactions as well as kind of like moving BTC from the bridge into the EVM execution environment. And then there's the execution layer, which is the Strata ref, which actually processes incoming EVM transactions and makes sure that they're like following the EVM spec, and then they would kind of get put into blocks.
I see.
By the sequencer.
Okay, so I think what I heard you say there was that Strata client is like that would be the actual like if I want to kind of monitor the pegging in of Bitcoin to the chain, that's kind of what monitor that process.
Yep.
The Strata ref would be, okay, once everything is on the Strata chain, then this is kind of monitoring the EVM execution.
Exactly.
Okay.
Exactly. And they kind of just run side by side. and that's your full node. And then you can set up your MetaMask or whatever to connect to your full node if you want to on localhost or like on a cloud. You'll just get like an RPC endpoint that you can plug into MetaMask, and then you're validating all of your own transactions and so on. Or you can just use a hosted RPC endpoint that somebody else is running.
Got it.
And at that point, it's just like an RPC endpoint that you would get for a Bitcoin wallet. You're just trusting that other third party to do all of the validation for you. In the future, we will have support for ZK-like clients because all of our blocks and block batches are proven in zero knowledge. It makes it relatively easy for us to develop a ZK-like client where you can verify that transactions are valid, like fully verify that transactions are valid according to the Strata consensus rules without actually having to like re-execute all of those transactions yourself. Instead, you just validate this proof and you know that the entire blockchain up until this proof was produced is valid, and you can then query the blockchain for any of the transactions that you're interested in to get your balance or validate incoming transfers and things like that. Without having to actually like execute all of the transactions in all of the blocks from Genesis. So it's a way to do like very efficient, lightweight, full blockchain verification.
Yeah. Very cool. That sounds it sounds like roughly analogous to the like compact block filters, but I imagine the actual cryptography going on there is much different since it's something from the ZK universe.
Yeah, it's even more lightweight than that.
Oh, interesting.
Was there anything else?
No, I was just going to confirm that, yes, it's even more lightweight than that because the prover that we are using, it's a constant size proof. So it doesn't matter if you have like any transactions, it's going to be always the same size, the proof. And it's also a recursive proof. So if you validate at point N, all points from 1 to N, they are automatically validated as well. So that's it.
Why don't we actually go look over here? I know there's this tab we pulled up over here. This might be fun to look at. So this is actually a look at your Block Explorer, right?
Yeah, so this is the Strata Block Explorer. We have another Block Explorer for the Signet, but I think this one's probably more interesting to look at because you can see blocks coming in. Looks like it has paused. It's a classic demo effect, I guess.
Oh yeah, you want me to refresh maybe?
Maybe refresh. It should refresh automatically to show when new blocks are coming in, but it was working as of 6 hours ago apparently. But
work in progress.
Anyways, yes.
The demo
very
gods.
Much, exactly. We've been cursed by the demo gods today. But this one will show your individual Strata transactions, as well as I guess maybe it's so slow because we're looking at the transaction page and not the blocks page. So
that might
maybe
be
if we look at the blocks page.
Yeah, we don't have transactions right now.
There we go.
All right,
Boom.
now we're live.
Sorry, I was playing around with the tabs before we started.
I wasn't paying attention either, so it's all right. So here, we can see that the blocks are coming in approximately every 5 seconds. And these are trusted confirmations. We call them pre-confirmations because there's a single sequencer who's producing these blocks. And so technically any time before they've actually confirmed the batch on Bitcoin, they could do a reorg on these blocks. And you're just trusting the sequencer not to do that. It's kind of in the sequencer's best interest not to do that because if they do it once, then trust is broken in them forever. And so there's kind of a business incentive not to do it. So that's like the short term, or that's like the trust model for the time being.
Would they lose the Bitcoin that they've put up?
They haven't put up any Bitcoin. So the sequencer right now is just a fully trusted role in the system. And when I say fully trusted, I just mean they're trusted for sequencing transactions. So they could reorganize transactions before they're actually put onto Bitcoin. In the future, we would like to add a penalty mechanism so that if they do try to reorganize transactions after they have produced a Strata block, then they get economically penalized. They might have some Bitcoin slashed or something like that. But for right now, it is just the users trust the sequencer to honor the order in which they have initially put the transactions in the block. Once the block batch has been confirmed onto Bitcoin, then the sequencer can't reorg those transactions unless they wanted. They would have to reorg Bitcoin to reorg that batch. So
that makes sense. Yeah, once it's on the main chain, it's good to go. Interesting. And so these are the blocks are coming in quick, and then so I mean I know this is a developer signet, so we're not going to see any transactions if we go in here, but so 0 transactions, but I imagine it would like list out all the transactions underneath that or something.
Exactly. Yeah. So if we go back to the transactions page, that would just show us some transactions, and we can see which block those transactions were included in. So if you click on maybe view details,
I see.
That'll kind of show you some more details about this particular block. And if we scroll back up, we can see there's a transactions tab that'll actually show you. In this case, there was only one transaction.
And then so it begins with 0x, so it looks like a EVM type of thing to me.
Yeah, all of the pretty much everything in the EVM environment starts with the 0x bytes, the addresses, the transaction IDs, the block transaction, the block IDs.
And so, I mean, you mentioned at the beginning here about like privacy as like a use case. Like, what would like a privacy type of situation look like on Strata?
Yeah, so there have been a number of different privacy protocols that have been invented for the EVM execution environment. There is a stealth address implementation that's been developed. There's a Tornado Cache is probably the most well-known privacy pool implementation. There's protocols. There's Railgun, which is it's not just a pool where users put fixed denominations and pull out fixed denominations, but it actually supports internal transfers as well. So you can deposit funds into this encrypted transaction environment and then do encrypted transactions within the kind of Railgun protocol. So you can, I could send you money and you will see that transaction coming in and know how much you've received, but you won't know who sent it to you unless I tell you. And the general public won't see any of the transaction details like the amount or the sender or recipient addresses, things like that. And there have also been other protocols like Aztec is another one that was developed, which is another shielded environment that moves some of the transaction data like off-chain. So there have been a number of different interesting privacy protocols that have been developed for the EVM, and there are other possibilities as well. People have done ring signature, like Monero style kinds of things.
ZK coins.
You could do a ZK coins or shielded CSV style protocol and have a smart contract secure bridge to transfer Bitcoin between the Strata chain and this shielded CSV protocol. So there are a bunch of things that you can do because of the fact that it's a fully expressive, programmable execution environment.
Yes, and so privacy is one of the use cases, but also you can, since as Light pointed out, you have like a fully Turing complete EVM execution environment with smart contracts. You can do Bitcoin backed loans. You can have all of the logic coded in a smart contract, and it's totally transparent. And so right now you do have some options of having like Bitcoin backed loans, but they use like the main chain. and they do have like a trust assumption, but you can defer all of the logic and the trust assumptions to like a smart contract, and it's totally transparent and auditable. So this is one of the use cases as well. It's pretty much like bringing the good stuff that we see in the EVM side of things into Bitcoin, and being backed by the main chain of Bitcoin, which is really good like trust assumptions and really good security model as well.
So what would, I mean, that does sound cool. Just like, if somebody else has already done it, and if it works, if we can use that and benefit from it and still have the, security benefits of, being embedded in Bitcoin blocks, that would be really cool. What would have to go like wrong? I'm just curious about like what would have to go wrong to exploit in a system like this, and kind of like thought experiment I'm looking for is just like, like say like, okay, for Bitcoin blocks to be like reorganized, or like, to have, for like Bitcoin blocks to be like reorganized, let's say, or for, blocks to be changed, you'd have to have some kind of miner who, you'd have to have miner centralization, over 51%. You'd have to have such a degree of mining centralization that nobody could compete with them for block creation, right? Like these are the kinds of like bad scenarios you'd have on Bitcoin main chain. Or for like Lightning, it would be things like, okay, if you had like a well-funded entity who wanted to target specific nodes, it would be like channel jamming or probing and things like that. Like what are like some like examples of like a hypothetical world where something could go wrong with something like this?
Okay, let's first start with like basic stuff, then we can go to more like elaborate stuff, and Light can help me out here as well. So basic stuff, so of course we are using Graph 16 as a prover that uses elliptic curve math, so quantum computers can break those things, so it is not quantum resistant. That is the first thing. That is like a failure. Also, there are some hash operations, so maybe if the SHA-256 or any other SHA-3 family of hash functions, they're inherently broken. This is also an issue, but those are like very theoretical, attack, like threat models. Another thing that might be something realistic, we could find like so we are using like Rust Bitcoin, we're using also Mystic2, like a bunch of other Rust crates, the whole code base using Rust. So there could be like a very big bug in one of those dependencies that then will be like pretty much like could like affect everyone that uses those crates, us included. This would be like another way for you to attack this. Also, the trust assumption for the bridge right now is one live operator that is honest. So if the bridge goes belly up with all of the operators, then your money is stuck there and you cannot peg out. So these are the basic ones. On the Bitcoin side of things, the sequencer, how it sequences deposits and withdrawals from the Bitcoin side of things, that is, we are seeing lots of discussions here at TabConf about EVM or MEV or miner extracted values, so MIVO and so on. That is, on the Bitcoin side of things, we are immune to that because our sequencer generates a proof, a zero-knowledge proof that we sequence all of the transactions and we dutifully process it, the deposits and the withdrawals and the state updates. From the EVM side of things, we are, as Light said, we are planning to do some sort of like economic disincentive for resequencing or reordering the transactions on the EVM side of things. I think those are the most basic ones. Of course, denial of service and those things for the RPC endpoints and so on. But
I would add a deep reorg on Bitcoin could be problematic because it could lead to double spends on the bridge. Like for example, if somebody deposits some Bitcoin they receive that Bitcoin on Strata, they do some Strata transactions, and then they get their Bitcoin back out on the main chain. And then there's like a deep reorg that goes back to go back and like undo their deposit.
Yeah.
But they still have the Bitcoin that they got from the withdrawal.
Yeah.
Or they still have their Bitcoin on Strata, depending on, you know, the exact sequence of events. And so that could be potentially problematic.
How deep is a deep reorg? Like how many blocks do you think?
It's a configurable parameter.
Yeah.
We haven't settled on the final parameters for the BitVM bridge design, but we have some equations that we're working with to give us an intuition of what might be a safe what we call finality depth for Bitcoin blocks.
Nice.
Suppose it's 6, for example. Then if there is like a reorg in 6 blocks, then we are safe. But this can be configurable, this can be changed, and probably we're gonna do like a big analysis of like reorgs over the reorg's depth on Bitcoin and settle on a number that is good enough to be practical, because suppose that we do like, okay, 12 blocks. So now you have to wait 2 hours to bridge in and out. So that is maybe not good.
Yeah.
But if you do something shallow, like 1 or 2, pretty much the risk is plausible for a deep reorg on mainnet. Yeah.
Yeah. Yeah. And in practice, we think that longer waiting periods for deposits and withdrawals are not necessarily deal breakers, because we've seen in practice that there are third-party services that will pop up to enable much faster transfers between different Bitcoin layers. For example, Bolt is a company that has become very popular amongst Lightning users for transferring coins between the main chain in Lightning or the main chain in Liquid, or Lightning and Liquid, and kind of these different layers. And so we envision that there could be like many of these different service providers who would actually provide much faster kind of transactions between the different layers.
That makes sense. So I guess we're kind of getting up on time here. I think just kind of final words. That makes sense. There's you're thinking about the different failure scenarios here. I guess I'll just be curious here to kind of wrap this up. Like, what are you looking for next with this project? Are you looking for more engineering? Do you need more people like downloading your binaries, testing it out? What?
Yeah. So call of action. First, we are hiring. So if you are an engineer, you like Rust, you like zero knowledge, and you are excited about like new stuff in Bitcoin, especially BitVMs and zero knowledge proofs, visit openlabs.io, go to careers and send your CV. Definitely, we do have go to our Telegram channel. We do have a Telegram channel. Go to stratabtc.org. And there you can fill in the form if you want to like go and take a look at our DevNet. And this is invite only for now, so you just fill in a form, go to our Telegram channel for support, and you'll be able to, once you get your invite, to start developing or using the Strata BTC and the bridge and the peg in, peg out, the bridge in and bridge out. The faucet as well. What else?
Yeah, I would say that's it. We also have the docs page that we've been looking through, docs.stratabtc.org, if you just want to learn more about how Strata works. And as Jose mentioned, all of this is on GitHub. So if you find any problems or you have any questions, you can maybe open an issue on GitHub in the docs repo, or just hop into the Telegram channel. We're always happy to chat.
Okay, awesome. Well, thanks very much for your time, guys, and look forward to hearing the Rollup talk later today.
Cool. Thank you, sir.
Thanks for the opportunity.
Hey, thanks for listening. I hope you enjoyed this episode. If you want to learn more about anything that we discussed, you can look for links in the show notes. That should be in your podcast player, or you can go to atlbitlab.com/podcast. On a final note, if you found this information useful and you want to help support us, you can always send us a tip in Bitcoin. Your support really helps it so that we can keep bringing you content like this. All right, catch you later.